Assalamu alaikum wa rahmatullahi wa barakatuh. This is Nazar Ibrahim, and we are discussing today about probability topic, a topic of 0580 syllabus mathematics, IGCSE, right? And as you all know, this is a project of teaching by SM, right? And as we have we have this intention that the revenue generated by this project for the first 6 months will be donated to Palestinian people. So I would like to ask all of the viewers to kindly support our cause. Jazakallah khair. So the first question of probability, right? Probability first means that we are actually calculating the possibility of an event, right? That either this event can occur or not, the possibility, right? And the probability here, when we are talking about possibility, so the probability of an event which is denoted by p, the bracket x is that event, right, lies between 0 and 1, uh, greater than 0, greater than equals to 0, less than equals to 1, right? There's a general rule for probability. Okay, the formula for probability is favorable outcome, the outcome which we are taking out, and total outcomes. Okay, that we will learn that how this formula will be used, inshallah. Okay, so the first question is: Simon has two boxes of cards. In one box, each card has one shape drawn in on it, that is either a triangle or a square. In the other box, each card is colored either red or blue, right? Two boxes are there. One has shapes drawn triangle or square. The other box has cards colored either red or blue. Simon picks a card from each box at random. The probability of picking a triangle card is T. So if the probability of picking a triangle card T, and we know that they are just triangles or squares, so the probability of picking card square will be 1 minus T. Okay, the probability of picking a red card is R. We know that the cards are red or blue, so the probability of picking a blue card is 1 minus R. Okay, complete the table for the cards that Simon picks, writing each probability in terms of R and T. So one is given to us, that is square and red. So when the probability we are finding out as AND, right? This event and this event both should occur, square and red. So the probabilities are multiplied, right? So probability of a square card is, which we calculated as 1 minus T, right, multiplied by the probability of red card is R, so 1 minus T into R. So probability of a triangle card is T, okay, and the other probability of red card is R, so TR. Probability of a triangle is T, and it comes to blue is 1 minus R. Probability of a square card is 1 minus T, and probability of a blue card is 1 minus R. Clear? Okay, let's move to the next question. Question number 2. The diagram shows a fair spinner. Fair means that every outcome has equal chances to occur, right? So 1, 3, 3, 4, 6. Okay, let's move forward first. Complete the table for the total scores. You can see that scores on first spin, score on second spin. Anna spins it twice and adds the scores. Complete the table for the total score. Okay, three rows are done for us. We just need to add them up. 4 plus 1, 5, 4 plus 3, 7, 4 plus 3, 7, 4 plus 4, 8, and 4 plus 6, 10. 6 plus 1, 7, 6 plus 3, 9, 6 plus 3, 9, 6 plus 4, 10, and 6 plus 6, 12. Right? Write down the most likely total score. Most likely means the most occurring. The most occurring over here is 7, 7, 7, 7, 7, 7. 7 is 6 times, right? Any other score which is 6 times? 6, 4, 6 4 times, and 9, no, 4 times, 10 2 times, 5 is 2 times, 4 is 4 times. So 7 is the outcome which has occurred 6 times. So 7 is the most likely total score. Okay, okay, let's move further. Okay, find the probability that Anna scores a total less than 6. Less than 6. First, I have to write it again so that we can do this question as well. 4 plus 6 10, 6 plus 1 7, 6 plus 3 9, 6 plus 3 9, 6 plus 4 10, 6 plus 6 12. Okay, less than, total less than 6. Probability to find out that a total less than 6. So less than 6 means 5 4, right? So 5 4 4 2, okay, 4 4, okay, 1 2 3 4 5, okay, this, okay, this one is also included. 1 2 3 4 5 6 7. 7 are those numbers, those sums which are less than 6. So 7 are the favorable outcome, and the total outcomes are 1 2 3 4 5. 5 into 5 is 25, right? The total outcomes are 1 2 3 4 5. One row has 5, so 5 rows, 5 into 5 is 25. So 7 upon 25 is the probability for total less than 6. A total of 3. Total of 3, we have no total of 3, so the probability of underscore total of 3 is 0. Clear? Okay, let's move further. Question number 3. The probability that Stefanik wins her next tennis match is 0.85. Okay. Okay. So find the probability that Stefan does not win her next tennis match. So for, if I know the probability of an event to occur, if I want the probability of not that event to occur, so just subtract it from 1. So probability of not winning 1 minus 0.85 is 0.15. Clear? Very simple. Okay, moving to the next. Question number 4. Question number 4 is the probability of that Pedro scores a goal in any match is 2.5. Calculate the probability that Pedro scores a goal in each of the next 2 matches. So in any match, the probability that Pedro scores a goal is 2 upon 5, right? So in the next 2 matches, 2 upon 5 and 2 upon 5. Next 2 matches. It means that the Pedro should score goal in the match in the next match as well. So 2 upon 5 and 2 upon 5, which means that 4 upon, it will be 4 upon 25, right? Is it clear? Okay, let's move further. Question number 5. A box contains 3 blue pens, 4 red pens, and 8 green pens only. Find the probability a pen is chosen at random from the box. Find the probability that the pen is green. So simply the favorable outcome is 8 green pens, and the total pens are 3 plus 4 7, 7 plus 8 15. So 8 upon 15. Okay. Another box contains 7 black pens and 8 orange pens only. 2 pens are chosen at random from this box without replacement. Now let's discuss what without replacement means. Calculate the probability that at least 1 orange pen is chosen. Okay. Now the second case is the box contains 7 black pens and 8 orange pens. 7 black, 8 orange. Okay. 2 pens are chosen at random from this box without replacement. Okay, without replacement means when one pen is taken out, it is not put again, and the second then pen is chosen. So calculate the probability that at least 1 orange pen is chosen, right? So at least 1 orange pen means that there can be many cases, right? For example, if I pick one, the other one is orange and the other is black. Second case is first is black, second is orange. Okay, at least means that 1 orange pin should be there. So there can be two. So the third case will be orange, orange. So this case can be there, this case can be there, this case can be there. So all these properties will be added. Now how to calculate the first case probability? Orange is 8 up 8 and the total are 8 plus 7, 15. Multiply by first is orange and second is blue. So for black, sorry, black blends are 7 and total now are remaining are 14, right? Okay. Second case, first is black means 7 upon 15 total, multiply by orange, orange 8 and remaining are 14. Clear? Okay. Third, first is orange, second is orange. First is orange is 8 upon 15 total, multiply by how many are left? 7 orange pen are left. And how many total are left? 14 because without replacement. Right? Okay. Now solving this up. Uh, 2 4s are 8, 2 7s are 14. Okay, 7 1s are 7, 7 1s are 7, 7 1 7, 7 1s are 7, 7 2s are 14. Okay, 2 1s are 2, 2 4s are 8. Okay, 7 1s are 7, 7 2s are 14, 2 1s are 2, 2 4s are 8. So 4 1s are 4 upon 15 plus 4 upon 15 plus 4 upon 15. Right, it will be 12 upon. So 4 plus 4 plus 4, 12 upon 15, which is equal to 3 4s are 12 and 3 5s are 15. It will be 4 upon 5. Clear? Let's move further. Okay. Question number now 6. In question number 6, we have box A and box B each contain blue and green pens only. Raphael picks a pen at random from box A and Paulo picks a pen at random. Paulo picks a pen at random from box B. Okay. The probability that Raphael picks a blue pen is 2 upon 3. The probability that Raphael picks a blue pen is 2 upon 3. Okay. Raphael is picking from box A and Paul is picking at random from box B. And box A and box B each contain blue and green pens only. Blue and green pens only. Okay. Find the probability that Paul picks a blue pen. Okay. So what we have, the probability that Raphael picks a blue pen is 2 upon 3. The probability that both Raphael and Paul picks a blue pen is 8 upon 15. To calculate the probability of Raphael and Paul both pick a blue pen is Raphael pick a blue pen is 2 upon 3 multiply by Paul pick a blue pen is x, and in total 8 upon 15 is given to us, right? Getting my point? The probability of Raphael and Paul both pick a blue pen is 8 upon 15, and how to calculate it? 2 upon 3 for blue pen of Raphael probability, and Paul, we are not aware of Paul picking a blue pen, so that is x. So multiplying that is the answer which is given to us, 8 upon 15. So solving this, 8 upon 15 multiply by 3 upon 2. So 3 1 are 3, 3 5 are 15, 2 1s are 2 and 2 4s are 8. That is 4 upon 5. Is it clear? Okay. Find the probability that both Raphael and Paul pick a green pen. Find the probability that both Raphael and Paul pick a green pen. So do we know that Raphael if picks a green pen, what is its probability? Are we aware of that? Yes? Okay. So we have, if we have given blue pen's probability of Raphael, so the green pen of Raphael, probability of green pen for Raphael will be 1 minus 2 upon 3, which is equals to 1 upon 3, right? Now the probability for for the this is 4 upon 5. 4 upon 5 probability for Paul pick a blue pen, right? So for Paul picking a green pen is Paul for 1 minus 4 upon 5, which is equals to 1 upon 5. So the probability for Raphael picking a green pen is 1 upon 3. For probability for Paulo picking a green pen is 1 upon 5. So multiplying both 1 upon 3 multiplied by 1 upon 5, that is Paul. We can write it as Paul probability of picking a green pen and Raphael multiply. And Raphael probability for picking a green pen 1 upon 3 into 1 upon 5 is 1 upon 15. Clear? Okay, let's move further. Question number 7. Question number 7 is the probability that Kim wins a game is 0.72. In 1 year, Kim will play 225 games. Work on an estimate of the number of games Kim will win. Now here the relative frequency will come into play. We are having, which is also called relative probability, we are having the probability of Kim winning a game 0.72. So what probability formula is? Probability formula is favorable outcome upon total outcome, right? So probability of the Kim winning a game is 0.72 and the total games which he is playing are 225, and favorable outcome, that how many games will he be winning, is x. So x is equals to 0.72 multiplied by 225. So multiplying this 0.72 multiplied by 225, 162 games will be the number of games which he will be winning. Now this is also called, which we have used over here, this is also called relative frequency, right? Which we have used. So in normal terms it is also called relative frequency. In the formula for this remains almost same, the values are placed like that only, but in relative frequency we are estimating a result based on the uh, events get done, right? Like he said that the 1 year Kim will play 225 games and the probability that he wins a game is 0.72. So this result is somewhere decided on some cases, right? That's why. Is it clear? Okay, let's move forward. Question number 8. We are having a group of 200 people were asked which city they would like to visit next. The table shows the results. Cities are given, number of people are given, right? Okay, 50 will say London, 80, 48 say Paris. Okay, a person from the group is chosen at random. Write down the probability that this person would like to visit either Paris or Tokyo next. Paris probability is 48 upon total is 200, and since it is or not and, so plus Tokyo is 46 upon 200. So add them up, 40 plus 40, 80, 88 plus 6 is 94. 94 upon 200 will be the probability for the person visiting either Paris or Tokyo next. Is it clear? Yes. So we can solve this further. It will be 47 upon 100 by dividing by 2. So 47 upon 100. Okay. Two people are chosen at random from the group of 200. Okay. Find the probability that one person would like to visit London next and the other person would like to visit New York next. Give your answer as a percentage. So the London one is 50 upon 200 and other person would like to visit New York next. So that is 56, right? Okay. Now this can be case, or the other case can be the first one is want to New York, and then London, right? So two possibilities: London, New York, or New York, London, right? Adding both because this can be case or this case, right? So adding this up, 50 first solving these both, or you can multiply it by 2 as well, because both are same, right? This will be 50 upon 200 means 1 upon 4. 50 ones are 50 fours are, okay. And from here you can use 4 ones are 4, 4 fours are 16, 4 fives are 20, 0, okay. And then you can further simplify. 2 sevens are 14, 2 twos are 4, 2 fives are 10, so it is 7 upon 25, okay. So 1 into 7, 7, 4 and 25 is 100, plus again 7 upon 100, which is equals to 14 upon 100, and since they are 14 upon 100, right, which is equals to 0.14, right. And if I want to calculate it in percentage, right, so it will be 0.14 multiplied by 100, it is around 14%, right, 14.1 as well, because if you simplify it will be near to that 14% or 14.1%. Is it clear? Okay, moving to the next question. Question number 9 is the diagram shows 5 cards, 1, 2, 3, 4, 5. 2 of the cards are taken at random without replacement. Okay, find the property that both cards shows an even number. How many even numbers are there? 2 and 4. So the first is 2 cards, 2 upon 5 will be the first probability. And since it's without replacement, now total cards left are 4. 1 is taken out as even, so 1 is left. 2 ones are 2, 5 fours are 20, 2 ones are 2, 2 tens, 1 upon 10 is the probability. Is it clear for question number 9? Okay, let's move further. I hope everybody is understanding the questions. Okay, question number 10. The probability that the school bus is late is 9 upon 10. If the school bus is late, the probability that the SEB travels on the bus is 3 upon 16. If the school bus is on time, the probability that SEB travels on the bus is 3 upon 4. Okay, now there you can see that there are two things involved, right? Two events are going on, late or not late. And if the school bus is late, he will travel by bus is this. And if a bus is on time, there's some events, right? So when we have 2 3 events, we try to go on with the tree diagram, right? So the first is late, not late, right? So for probability for the school bus is late is 9 upon 10, and if not late, so 1 minus 9 upon 10 will be 1 upon 10. This will sum up to 1. Okay, if the school bus is late, then the probability that SEP travels on the bus travels, not travels. So travels 15 upon 16, not travels 1 minus 15 upon 16 will be 1 upon 16. Okay, if the bus is on time, if the bus is on time, the probability that SEP travels on the bus is 3 upon 4. Not late means on time. So travels or not travels. So travels, the probability is 3 upon 4, and not travels 1 minus 3 upon 4 is 1 upon 4. Okay, find the probability that the SAP travels on the bus. So travels, there are two cases, late and travels, not late and travels. So late and travels, probability late and travels, plus probability of not late and travels. So probability of late is 9 upon 10, travels is 15 upon 16. Probability of not late is 1 upon 10, then travel is 3 upon 4. Okay, solving this, 5 twos are 10, 5 threes are 15, right? Okay, and 9 threes are 27, and 2 16 twos are 32, plus 1 3 is 3 and 10 4s are 40. Is it clear till here? Okay, now just simplifying this up so that we can get the answer, right? 32 and 40 means we can take the LCM 2 1 is 6 2 is 12 2 0, okay, 2 8 10, okay, 2 4 5 2 2 5 2 1 5 and 5 1. 2 to the 4 4 to the 8 2 to 16 6 to the 32 32 5 is a 160. So 32 5 160, 27 into 5. So 27 into 5 is 135 plus 44 is a 4 3 is 12. Okay. So 135 plus 12 is 147 upon 160. Clear? Okay, let's move to the next. Question number 11. In question number 11, Harris is taking a driving test. The probability that he passes the driving test at the first attempt is 0.6. If he fails, the probability that he passes at any further attempt is 0.75. Calculate the probability that Harris passes the driving test at the second attempt. Okay. So the probability that he passes the driving test in the first attempt is 0.6. So probability that he fails in the first attempt is 1 minus 0.6, which is equals to 0.4. If he fails, the probability that he passes at any further attempt is 0.75. Okay. So the passes the driving test at the second attempt. So first attempt definitely he will be failing. So failing's probability is 0.4 and passing it the second attempt is 0.75, right? So 0.4 into 0.75, 0.4 into 0.75 is 0.3. So we have 0.3 as the probability of passing the driving test at the second attempt. Okay, it takes no more than 3 attempts to pass the driving test. No more than 3 means, yes, no more than 3 means passing in the first attempt. Okay, there is a possibility. It means that there can be several cases. The one case is passing, probability of passing in the first attempt. Okay, probability of passing in the second attempt. Okay, and probability passing in the third attempt. We cannot exceed it because he has asked to take out the probability that no more than 3 attempts. So till three cases are there. Probability of passing in the first attempt is 0.6. Second attempt we just calculated 0.3. Third attempt will be 0.4 and failing in the second attempt will be 0.25, 1 minus 0.75, and passing in the third attempt is 0.75 because in any further attempt the passing probability is 0.75. So 0.6 plus 0.3 plus, now multiplying this 0.4 multiplied by 0.25 multiplied by 0.75, so that is 0.075, right? So adding all these up, 0.6 plus 0.3 is 0.9 plus 0.075 is 0.975. I hope that's clear to everyone. Okay, let's move further. Question number 12. Question number 12, we have here a bag contains blue, red, yellow and green balls only. Blue, red, yellow and green. A ball is taken from the bag and random. The table shows some information about the probabilities. Okay, the probability of blue is 0.75, red is 0.2, green is 0.43. We know that the total probability is 1, right? So to find out the yellow probability, add all and subtract 1. Add all and yellow is x, so 1. So 0.15 plus 0.2 and 0.43, right? 0.78. Okay, this is 0.78. So x is equals to 1 minus 0.78, which is equals to 0.22. So the probability of yellow is 0.22. Complete the table. Done. Second, Abdul takes a ball at random and replaces it in the bag. Now the condition is replacement with replacement. He does this 200 times. find how many times he expects to take a red ball. Okay, the probability of taking out a red ball is 0.2, and formula is favorable outcome. I mean, how many times he expects to take a red ball is x, we don't know, and the total times which he is doing this event is 200. Okay, so x is equals to 200 multiplied by 0.2. So 200 divided by 0.2 is 40. Okay, so 40 times he can expect to take a red ball out. Clear? Okay, let's move to the next. Question number 13. Sophia has a bag containing 8 blue beads, 7 red beads only. She takes one bead out of the bag at random and replaces it. Okay, placement. She does this 90 times. Okay. By the number of times she expects to take a red bead. So if I want to take out that how many times she is getting red bead when she is doing this event 90 times, so first I should know the probability of getting a red bead. So the probability of getting a red bead out in any case is 7 upon total is 8 plus 7, 15. Okay, now using this probability 7 upon 15, how many times G is doing this event? 90 times. X over here, this implies x is equals to 7 multiplied by 90 upon 15. 15 ones are 15, 15 6 is 90, 7 6 is 42. So 42 times you can expect to take a red bead out. Clear? Again, the same concept which is used previously. Okay, let's move further. Question number 13 is done. Question number 14. Okay, in question number 14, a bag contains 7 red discs, 5 green discs, and 2 pink discs. Helen takes one disc at random and records the color and replaces it in the bag. She does this 140 times. How many times she is doing this? 140 times. Find how many times she expects to take a green disc. Again, I should know what is the probability of green disc. So that will be green discs are 5, and in total there are 7 plus 5 12, 12 plus 2 14. So 5 upon 14, favorable outcome upon total outcomes. Okay, find how many times she expects to take a green disc. 140 times she is doing this event, so 5 upon 14 is equals to favorable outcome is unknown and total are 140. So x is equals to 5 upon 14 multiplied by 140. 14 ones are 14 tens are 5 tens are 50. 50 times you can expect to take a green disc. Okay, second part, Helen adds 9 green discs and some pink discs to the disc already in the bag. So now the total green discs are 9 plus 5, 14. Red discs are 7 and the pink discs are the some pink discs added, so 2 plus x. 2 were already and x are the number of pink discs which are added. The probability of taking a green disc is now 2 upon 7. Okay, so we know that the total green discs now are 14 and the probability of green disc now is 2 upon 7. So using this 2 upon 7 and the total green discs now are, I guess, 14, right? Red are 7, pink is 2 plus x. So we are given the information that taking the green discs now is 2 upon 7 and total green discs are 14, right? So total green discs are, we have 14 and the total outcomes which are the total discs, that is 14 plus 14 are green discs and 7 are red discs and 2 plus x. Okay, so simplifying this, 2 upon 7 is equals to 14 upon 14 plus 7 21, 21 plus 2 23, 23 plus x, right? So 23 plus x into 2 is equals to 7 into 14. We have 14 into 7 as 14 into 7, 98, right? This is 98. Okay, 23 into 2 is 46, 2 into x is 2x, 98. Okay, so doing this here further, so 2x is equals to 98 minus 46. So 98 minus 46 is equals to 52, right? So x is equals to 52 upon 2 is 26. So x is the number of balls pink discs which are added, right? So now total pink discs are 2 plus x, which is equals to 2 plus 26, I guess. 2 plus find the number of pink discs that had added to the bag. Okay, we just wanted to find out the number of pink discs that had added. So added discs are 26. Clear? Okay, let's move further. Question number 20. Question number 15. The probability that a train is late is 0.15. Then the probability that the train is not late. So for not late is 1 minus 0.15, which is equals to 0.85. Very simple. 0.85. Okay, let's move further to question number 16. Right, in question number 16 we have a bag contains 3 blue buttons, 8 white buttons, 5 red buttons. 2 buttons are picked at random from the bag without replacement. What are the probability that the 2 buttons are either both red or both white? So both red one case, both white another case, plus, okay. So both red is 5 upon without replacement, right? Not with replacement, without replacement. So 5 upon total are 8 plus 5 13, 13 plus 3 16, 5 upon 16 multiply by how many red are remaining? 4 upon 15, right? Without replacement, plus white probability is 8 upon 16 multiplied by 7 upon 15. Am I clear? Okay, 4 ones are 4, 4 4 is 16, 5 ones are 5, 5 3 is 15. So, okay, 2 8 ones are 2 8, 8 2 is 16. Okay, so now this is the starting is 1 ones are 1, 1 upon 12, 4 3 is 12, plus 1 7 is 7, and 2 15 is 30. Is it clear till here? Okay, now just adding both up to get the answer. So 1 upon 12 plus 7 upon 30, it means that I need to take out LCM. Okay, and in LCM we have the two numbers that are 12 and 30. Am I right? Okay, so 12, 30, 2 6 is 12, 2 15 is 30, 2 3 is 6, 15, 3 1 the 3, 5 and 5 1 the 5, 2 to the 4, 4 3 the 12 and 12 5 is the 60, 12 5 is the 5 1 the 5 is the 5, 32 is the 7 2 is the 14, so 14 plus 5 19 upon 60 is the given answer of the probability that two buttons are either both red or both white. Right, I hope you guys understood the all the questions, and I expect that you all will inshallah uh, look more videos as well. So we will be uploading more and more about each and every topic. I would like to again say that this support our cause, and look each and every video, subscribe us and support our cause, so that the funding which we'll be generating through these videos inshallah will be given to the Palestinian people for the first 6 months. Jazakumullahu khaira. Assalamu alaikum wa rahmatullahi wa barakatuh.